Today we're doing 7.1, which talks about ratios and proportions. We've already actually covered some of this, so it should look familiar. There are two definitions that we need to get down. The first one is ratio, and this is going to be a comparison of two quantities by division. So if we think of division, I think of fraction. So if we look at this first one, we can say that there are 7 shaded to 5 non-shaded. Or we could look at this one and say that there are 28 shaded to 20 non-shaded, and these two actually mean the same thing. You can also write it as a fraction. So we can also think of this as 7 are shaded out of a total of 12, and here we have a 28 shaded out of a total of 48. And if you reduce this equals 7 over 12, which you'll see are the same, which leads us to our second definition of equivalent ratio. This definition is ratios that make the same comparison. So if you look at these pictures, the same amount is shaded, it's just represented in two different ways. So let's see if we can find two equivalent ratios. So let's start with this example. If I give you the ratio of 6 over 8, or 6/8, to find one that's equivalent or equal, because you see that equa in there, we can multiply both the top and the bottom by the same number. Now the easiest is 2. So 6 times 2 is 12, 8 times 2 is 16. So the ratio is 6 over 8 and 12 over 16 are equivalent. But it's asking us to find 2. So if I go 6 over 8 again, instead of multiplying, we can also divide. These both can be divided by 2. So 6 divided by 2 is 3. 8 divided by 2 is 4. So 3/4 is also equivalent to 6/8 and also to 12/16. So I want you to try one on your own. Find two equivalent ratios to the ratio of 48 over 27. See if you can go up and if you can go down. So what you should have done is I'm going to multiply the top by 2 and the bottom by 2 and change this to 96 over 54. That's one of my equivalent ratios. If I start with 48 over 27, I notice that I can't divide both of these by 2 because this second fraction ends in a 7. So 2 doesn't go into 7, so I can't divide by 2, but I can divide by 3. So if I divide the top and the bottom by 3, I get 16 over 9. So my two equivalent ratios are 96 over 54 and 16 over 9. We need to get the definition of proportion down. And a proportion is going to be ratios, so more than one, that are equivalent, so equal. And they're going to be identical when written in simplest form, so when we reduce to the smallest amount. So what we're going to try is we're going to see if we can find two ratios that are equivalent. So if I give you 7 over 21 and 2 over 6, I want to know if those are equivalent. So I'm going to start with 7 over 21. Well, if I reduce this because I want to get it in simplest form, I can divide the top and the bottom by 7 to make this 1/3. So this is the fraction 7/21 in simplest form is 1/3. So now we need to do 2/6, and we need to see if in simplest form, if that also equals 1/3. So if I look at 2 over 6, I'm going to divide the top by 2 and the bottom by 2, and I get 1/3. Since they are both 1/3, yes, they are equivalent, which means yes, they are in proportion. Let's try another one. Let's try the ratios 9 over 12 and 16 over 24. Let's see if those are in proportion. So again, let's pull them out. Let's do 9 over 12 and put that in simplest form, so as small as it can go. Let's divide the top and the bottom by 3, and you get 3/4. Now let's do the same thing for 16 over 24. Again, I want to put it in smallest form. So maybe you start by saying, okay, I know that I can take a 4 out of both. And you say this equals 4 over 6. Well, that's not in simplest form because I can still take out a 2 from top and bottom. So again, it's okay if you have to do it multiple times. And we get 2/3. So I'm looking at 3/4 and 2/3. Those are not the same fraction, so these are not in proportion, or they are not equivalent. Can you find a proportion in here, though? What is proportionate to 9 over 12? Well, 3/4 is. So 9/12 and 3/4 are in proportion. What fraction is proportionate to 16 over 24? Well, you can say 4/6 and 2/3. So while those two are not proportionate, they do have ones in here that we found. Alright, let's see if we can try this question. It says, at 4 degrees Celsius, 2 cubic feet of silver has the same mass as 21 cubic feet of water. At 4 degrees Celsius, would 126 cubic feet of water have the same mass as 6 cubic feet of silver? So this might sound overwhelming, but let's break it apart. It says 2 cubic feet of silver has the same mass as 21 cubic feet of water. We can write that as a proportion. So we know that 2 cubic feet of silver has the same as 21 cubic feet of water. So we did silver over water. That was our proportion. And it says, would it have the same? So that means, is it equal? So if we look at this second ratio that we want to make, 126 cubic feet of water to 6 cubic feet of silver. Well, if I'm looking at 6 cubic feet of silver, we did silver on top, so I have to do 6, and then we want to put 126 on the bottom because that's where water goes. Now they want to know, do these equal? So are they in proportion? So we need to simplify this to see if they are the same and if they're equivalent. So let's do 2 over 21 first. Can we reduce 2 over 21? You cannot. That is in simplest form, so 2 over 21 would stay the same. Let's do 6 over 126. Well, we can divide these both by 6. 6 divided by 6 is 1, and 126 divided by 6 is 21. So if we look at these two, are those equivalent? No. So these are not in proportion, or they're not equivalent, so they do not have the same mass. So when you're looking at these problems, setting up a ratio with words will help you at the beginning. You can now do your exit slip.